So our question now is that we want to find the arithmetic sequence of the following set of numbers. So these are 3, 5, 7, 9, etc. Yeah, so continuous. Okay. So the first question might be something like this. Find the common difference d, right? So find the value of d. Okay. So what's the common difference? The common difference is what you add on every single time. So it's the plus 2 here, as you can see. So plus 2 each time. Yeah? Okay. So it's basically the second term. Just take the second number, so the 5, minus the first term, the 3, right? So that's one way to find it. So in this case, this would be 5 for the second term and 3 for the first, giving us 5 minus 3 or 2. Fine, okay. Another way might be to find the third term, which is a 7, minus the second term, which is a 5. So this would be 7 minus 5, giving us 2. Great, okay. Now, of course, we want a more mathematically rigorous way to do this. So what we might do is we might label each of these numbers something, right? So the first digit would be, for example, U1, the second would be U2, third one would be U3, fourth U4, and so forth. Okay, fine. So D would then be U2, so the second term, minus U1, the first, right? So 5 minus 3 again, gives 2. It would also be U3 minus U2, giving us 2 as well. And also things like U100 minus U99, giving us 2 as well. Okay, great. So for part B, we might want to find something like the 8th term. So here we see the first 4 terms, but say we want to find 8 terms instead. Okay. So to find this, we can see that between the first term and the 4th term, we have 3 common differences, right? So it's kind of 4 minus 1 common differences, so 3, right? Between the so for U8 then, it's 8 minus 1 common differences, so 7 common differences between U1 and U8. Okay, so U8 is then U1, which is sort of our starting value, plus 7 times the common difference. So 7 common differences, right? So U1 is 3. So 7 then times the common difference, which was 2 as we said. 7 times 2 giving us 3 plus 7 times 2. This is 14. 3 plus 14 giving us 17. Great, okay. So this allows us to find any term that we want down the line. So we could also find U100, U500, and so forth. Okay? That's just an example. Okay. So for part C, let's do something else. Let us find the summation of the first 8 terms. So the way we write this is we write a capital S with a small 8 here. Okay. So what this basically means is that we are taking our entire sequence and we're adding it up, or the first 8 terms of it at least. So take our 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 and we add this all up. Now, say with it, so in this case, it would be quite easy to simply add this all up. If it was, say, S of 80, so summation of 80 terms, this would take much longer and would probably not be the smartest way, right? We're doing S of 8 in this case. So I'll show you a formula to do this. I think that's the best way. So the formula is as follows. So S of n being the number of digits you have here, so number of numbers, so in our case it's 8, is n over 2 times u1 plus un. Fine, okay. So, in our case, n is 8 over 2, u1 is our first number, so 3. un is the last number, so in our case it's 17. And we apply this. 8 over 2 gives us 4 times this is 20. It's 4 times 20, which is just 80. Another way to imagine this is that you see that there are 4 pairs of 20. So if you take a look at the first term and the last term, 3 plus 17 is 20, right? If we take the next two terms, so 5 plus 15 is 20, 7 plus 13 is 20, and then 9 plus 11 is 20, right? So we have 4 pairs of 20, and the 20 consists of the first term plus the last term. And that's where this formula actually comes from. That's all, and thanks for listening.